Okay, now can you hear me? Yeah, all right. Thank you. I want to repeat what I was saying to talking to myself. That the exam is next Monday. Make sure that you are on time. And also you're supposed to do, and I hope that you do solve the exam by yourself. I was saying before, and I'm going to repeat that we had the technology to watch it. So make sure that you do solve the exam by yourself. And I do need to see your work. At 3 o'clock, you're going to be able to download the exam. And also, I'm going to put the exam on the screen for 10 or 15 minutes after I'm going to remove it. And you have until 4:20 to finish your exam, and you need to upload it. And some of you that take pictures, it's going to take forever because the file is going to be huge. You have to do a PDF, a clean PDF, and send it to me. If please don't email the exam to me. Don't email the exam to me. Just upload it. And there is an overlap at 4:20. You're going to be able to download the bonus. And officially, the exam is supposed to finish at 4:50. I'm going to give you 10 minutes. So by 5, you need to upload the second question. And again, do not send it to me. Just upload it. Any questions about this? Okay. Something else that I need to tell you. This is the application form for the Eisenhower Transportation Scholarship. It's about $10,000 per person, no strings attached, and includes a trip to Washington in January. And Dr. Diaz is in charge of scholarship, but he did not send me the whole information. So this is what I got. So I'm gonna ask Dr. Diaz to resend it to me, and I will put it in a folder that is called scholarship. And I do know that you have to have 3 letters of recommendation. Oh, sorry, two. One of them must be from a faculty advisor. So make sure that you read what is required because Dr. Diaz will not accept any application that is going to be late. But this is a great opportunity, very easy. Not too many people apply. Last year, we only had 2 people applying. So everybody that applied got the money. So don't forget, it's called the Eisenhower Scholarship, and I will upload that as soon as I get it from Dr. D. So if we ask you, it is like two in one. You talking about the letter? Yeah. Well, we'll talk about that later. You can find me. Look, a lot of people they have questions about the fixed end moment table. In the old time, we only had the left side. So in the old time, the only thing that we had was this side of the table. Now we have both sides of the table. Some of the old exams are solved by using this table, and it becomes confusing or very confusing whenever we use 4EI and 3EI. So the right hand side takes into consideration that sometimes at the end of a member there is a roller of a pin. So that means that the moment has to be zero. If there is a pin of a roller, there is no way that you're going to have a moment. If there is a moment, something is wrong. But I mentioned before that if you use this left-hand side fix and fix, you can obtain this right-hand side with fix to the left and roller to the right, or fix to the right and roller to the left. All that you have to do to create this fix at the left and roller on the right hand side, all that you have to do is remove this moment. The way we remove the moment, we put an equal and opposite, and we send 50% across, and the two moments now become 3PL over 16. If you do the opposite, if you leave this fixed and you put a roller in there, all that you're gonna do is put an equal and opposite and send 50% across. Also, it's gonna be 3PL over 16, but in the other direction. So all of these tables on the right-hand side were built by using the left-hand side. But you can use even if you have 3EI over L, you can start with this one, but it's better to use this one so you won't get confused. Some people, nothing wrong. If you have 3EI over L, you can either use this or use this one. But don't forget that the moment you have this case, the moment has to be zero. Another thing, I'm going to go through a whole bunch of all examples right now. And the only thing that I want you to know is this. This is a fixed support, so there is a moment. This is a rigid joint. There is a rigid joint, so it's going to be a moment BA and a moment BC. They're going to be moment because this is a rigid joint. When you look at C, it's also a rigid joint with three members. So you're going to have a moment in each one of these members. When you look at joint E, it's also a rigid joint. You're going to have a moment EC and a moment EF. So there are going to be moments on top of the column and on the right side of the beam. When you look at this column, it's fixed and there's a moment on the top, so you're going to have moments at F and at E. When you look at this column, there is a pin, so you are going to have a moment at C, but no moment at D. So now we have to decide if we're going to use 4EI or 3EI, and nothing to do with the loading. Using 3EI or 4EI, nothing to do with the load. It has to do with the ability of the member to resist a moment or to have moment equal to zero. So now I want to ask you, and I'm going to write it in there. A, B, and forget about 0.5 I, forget about the I. This in here is going to be 4EI or 3EI from A to B. Anybody? 4 or 3? 4. Definitely. So I'm going to put a 4 in there. And I'm going to put the EI, just a 4 in. PC, 4 or 3? Are you sure? Great. 4. This is going to be 4 EI. I'm not putting the whole thing. CE, 4 or 3 EI? 4. Great. So in here, this member, 4 or 3 EI? 3. Great. This member in here, 4 or 3? 4. Wonderful. So the moment BC is going to be WL squared over 12. The moment CV is going to be WL squared over 12. So we're going to use this. WL squared over 12 and WL squared over 2. This one, you're going to have a moment, fixed moment here, fixed moment. Look, to do this moment in here, to do this moment, they put this is plus 5 W squared over 192. They put a 5, they put a minus 5 W squared over 192, and then they send 50% across and combine this moment with this divided by 2 and gave you this one. So this case is not in the table. So the only thing that you need to do, you put this load in here and move this moment here and that moment to there. So look, this case is not in the table, but we know that the moment in here is going to be clockwise and we're going to be counterclockwise. The only thing that you need to do, you move this load to here. You move this moment to here and that moment to there. Is that clear? Yes or no? Yeah, visual. So it's sometimes very simple. Now I'm going to go to another one. This is fixed, pin, rigid joint, hinge, rigid joint. From how do we tell it's plus or minus? Okay, go back to here. Okay. Look, gravity load. The one on this, if you look at this, all of these are gravity loads. The ones on the left, they are counterclockwise. The one on the right, clockwise. The one on the right, clockwise or counterclockwise? The same as this. Look, for gravity low, the ones on the left counterclockwise, the one on the right clockwise. So this is exactly the same. Exactly the same. This value on the right hand side, so look, the one on the left, gravity low, always counterclockwise, this clockwise. This is the value that was on the other side. I move it to here, I move the other one to here. You can see it here. I put this value And here, this value there, the only thing that changed is that it was counterclockwise, now it's clockwise. This is what we have. So, what is the sign of this one? Plus or minus? Okay. Now let me see. There's a question on view. Can you explain why EF is 21? 21? Why? Moses, what are you talking about? Oh, the moment inertia. Look, thank you for clarifying it. Look, whenever you whenever you have a structure, the columns and the girder, they're gonna have different moment of inertia. And like they were helping me, is given. These values are given for this problem. Okay. So no, there was another question. Oh, look, number one on the review, tomorrow we're going to have the review from 11 to 1. So tomorrow I'm going to go over the problems that I posted today for the review. And so, Billy, can you wait until tomorrow, or really you want to know today? Can you wait until tomorrow, or you want to go over the problem, the review problem today? You can wait. Okay, good. So, another problem I was asking you. Now that you all are expert, is this 4EI or 3EI? I know you're not expert. 4, 3. What else? Okay, I have an exam tomorrow. Oh, okay. Christina, Christina have an exam at 11 tomorrow. How can you have a final there next week? How can you have an exam tomorrow? I already posted a solution. I already posted a solution for the review. Oh, highway. Well, I don't know why you shouldn't have highway tomorrow. Is that the final in highway? Oh my God. I don't know. We're not supposed to give the final, but that's not my problem. Anyway, so go back to this. Is 4 or 3? Okay. Okay, let's stop. Stop. I'm going to kill each one of you slowly. Because look, how many unknowns do we have here? How many unknowns? 3. And how many here? Altogether 5. How many equations do we have? We have 3 equations plus hinge and hinge. So is this determinant or indeterminate? Determinant. Determinant. So we cannot use 4EI, 3EI. You need to pay attention because in the past, I'm given a structure that is determinant, and people try to solve it as indeterminate. But I promise I will not give you that trick today because everything has changed, everything is online. So there's certain things that we have more time to look at them before. We don't have the time. This is being a crazy semester. I just want you to know, I want you to remember always count the possible components of the reaction. I knew that people were going to say 4, 3, nobody's going to give me the answer. So look, you need to wake up and count always all the possible components of the reaction and how many unknowns we have. Derek. Okay, let me see. Yes. Okay.
The
We
middle
have
of
47.
nowhere.
Yeah, just turn on microphone. So we have 47 of you.
Do you really?
Hey, turn that mic off. So we have 47 of you in here. The last portion of the semester were indeterminate structure. So it had to be indeterminate. So I had to make sure that you understood indeterminate structure. But what I'm saying to you, always, always, always find out how many unknowns we have.
Watch. Yeah, Hollywood, it's so good. That's literally what I was about to say.
Can't believe
Yes,
it.
it's amazing.
Tito is the one that is doing is in Hollywood. So on Monday, Tito is going to be in Hollywood during the exam. I'm glad that he had a job. Okay. So I was saying, don't forget to count all the possible components of the reaction and how many equations we have. It was just to see you're paying attention. Go back to another problem. Tell me, determinant or indeterminate? Indeterminate. Good. Because we had 3 and 3, 6, 7, 8. 8 minus 3 fifth degree on the. One of the confusing things in here is that this is a roller, but it is an interior support. This is a roller interior support. So this is a continuous beam, a continuous member. So over the support, there's going to be most of the time a negative moment. Over the support, a negative moment. So the moment at B is not zero. There is a moment at B, there is a moment at C. This is a continuous member. So there is a moment at B, equal and opposite BA and BC. There is a moment at C, equal and opposite CB and CD. So I in here is 20, I is 30, and I is 30. Right? So different moment inertia. From A to B, 4EI or 3I. 4. I'm going to write the whole thing. I don't want it to get confused. So it's going to be 4E20 over 25. 4EI over L. We do not have to worry about the units. You just put the way it is given. 4EI over 25. Now, Miguel is saying that this is 3. And so for Miguel and other students that they didn't say anything, if A were a pin, would section A be okay? So if A is a different problem, please don't get confused. Lillian is asking. Don't get confused. If instead of the fixed support, we had a pin in here. Number one, we need to check if I had a pin, is this still an indeterminate or determinate if I had a pin? In here. Indeterminate, right? Okay. But if I had a pin, the moment is going to be 0. So this member will be 3EI over L. So If the moment is zero, this will be 3EI over L. We modify the stiffness to solve the problem quicker and faster. So, no, I'm glad you asked. I'm glad you asked. So this will be 3EI over. Ask please because people are confused, believe me. From B to C, 403. Oh, man. Miguel, man, you cannot hit one that is right. Look, I said before, there is a moment, there is a moment here, and there is a moment. So this is going to be 4. 4E30 over 30. Now you cannot go wrong with this one. CD, 4 or 3? So, no more? 3 or 4? 4. So this is going to be 4E over 30 over 30. AB, the moment is going to be W square over 12 and W square over 12. PC, the moment a roller B and C because the beam is continuous. Well, Christina, that's a good question. So this is more or less the way this is going to deform. So you can see that this is a continuous member that is bent. The only thing that the roller is doing is putting a point to support this continuous beam, and so it's producing a change in the way this deflect, the curvature changes from the compression being in here on the top, compression being at the bottom. But the reason is that this is interior member, it's just bending, helping this beam to change the curvature, the same in here. That's why we have a moment in there. Thank you for this question. And so I was saying that W square over 12, negative, W square over 12, positive. W square over 12 negative, W square over 12. This law is exactly in the middle. This is going to be kind of clockwise, it's going to be clockwise. From the table, anybody write what is the moment in here? From the table, P. P over A, good. And P over A. So this is a very simple computation. I'm going to go to the next one. And remember, distribution factor, there are 2 at B, there are 2 here, and 0 and 0. Another problem. We use 3PL over 16. Okay. Sometimes, sometimes I don't see the question on time, but the question for this problem, that is fixed here and has the ability to resist the moment in here. The question is, can we use 3PL over 16? So whenever you look at this, this is QFZ058. I don't know who the person is, but I'm going to go Mr. QFZ058. Look, or from anybody that wants to help. When do I use 3PL over 16? When do I use, Eric? When do I use 3PL over 16? What is the condition that I have to use 3PL over 16? Look at this. When the end spin, exactly. Exactly, you got it right. So, okay, you got it. So I'm gonna, okay. Please feel free. So, you will. Okay. Every single problem I have to show you work. We don't believe in magic. We need to see how you guys. First question. Determinant or indeterminate? Count all the possible components of the reaction. Indeterminate, good. There's something important that we need to decide in here. And the decision that we need to make. Is there any way that this frame will move to the right or to the left? In other words, lateral movement or side sway? Okay, good. There is a lateral movement in here. So that means that we have to do two moment distribution. But distribution factors are the same, fixed moments are the same. So now we're going to decide it, and here EI is constant. Oh, how do we know if it's I where? Okay, good. There's no symmetry with the geometry, right? There's no symmetry with the geometry. To have symmetry with the geometry, we have to have in here, this has to be 20, and this column has to be 20. So there's no symmetry with the geometry. There's no symmetry with the loading. And so these are elastic structures that are going to deform. Then we had this pushing. This is pushing the wind blowing the structure. And this point load also trying to move this structure. So this structure, this joint, is going to move to here. This joint is going to move to here. And this joint is going to move to there. So we have a lateral movement because the joints are free to move, free to move, free to move. That is the reason why we had a lateral. If I had a wall in here or a wall in here, it will not move. In here, there's no way if you push this structure, it's gonna move either to the left or to the right. So that is why we have a lateral move. And how do we know? Okay, John is it leak. You understand that? Okay. So remember, lateral move. Now we have to look at column AB. Fixed, and this is a rigid joint. Moment and moment in here. This member BC, this is a rigid joint. It had 3 moments in here. This is a rigid joint, 2 moments. This is a pin, no moment. There is a fixed support, there is a moment. So member AB, 4 or 3, EI over L. 4, good. I'm gonna put 4 EI over 20. Member BC, 4 or 3? 4. 4 EI over 20. Now, one question. This is 4 EI over 20, and this is 4 EI over 20. When I compute the distribution factor from B to A, it's going to be this number divided by the summation of this number plus that number. When I compute distribution factor from B to C, it's going to be this number divided by this number plus that number. So distribution factor BA 0.5, distribution factor BC 0.5. Okay. Now Jeremy had a question. If there isn't a moment above N, if there isn't a moment above N, if there isn't a moment instead of 4, if 3, EI. Yeah, no, I know 3I, but look, not necessarily. Look, there's no moment at this end, so this is 3EI over there. Because this is continuous support, there's moment in here, this is going to be 4EI. The same happened in here. We had moment, 4EI. And moment, no moment, this is 3EI over there. So that's when we use the 3EI. But what about you say no moment in here and no moment in there, right? If I understand correctly, isn't a moment above N? Like for instance, if I had this and this, 3 or 4, nothing. This is the terminal. There's nothing here. This is, well, not 3, but you have to be careful, right? No. Just trying to make sure no entrapment. And make sure that I'm answering your question. You asking me the question. I didn't give you the question. That question came from Jeremy. So go back to this problem. But please ask questions because some of you never ask questions. I don't want you to get confused. We already have 4EI, and also I use this to tell you about the distribution factor 0.5. Now we're going to look at CD, 4 or 3? 4. So it's going to be 4EI over 30. But you do need to pay attention because when I give these problems, some people do 4EI with 20, when this is 30. What about CE? 4 or 3? 4. Over 20. And EF, 3. Another, I remember because there was a 2019, I remember mistaking here. Look, this is 15 and this is 5. 15 and 5. Can I use this formula here to find the fixing moment? Definitely, right? So this depends on the A and the B. But now we had a problem. Look, 0 is at the moment, 10 is where the pin is. Can I put this W square over 15, my fixed end moment, to do my moment distribution? Can I put in here the value W square over 15? Yes or no? No, no, we cannot do it. So what do we do? Look, pay attention. I know, Miguel. Pay attention to this. Exactly the same loading, but I had put fix and fix. There's a wall and there's a wall. Gravity load, this moment is gonna go in this direction, that moment is gonna go in that direction. Okay? So now I want you to look at this. Hopefully, you have your book. I want you to look at this. Okay? Look, on this side, W square over 20. On this side, W square over 30. On this, where the low is, W square over 20, W square over 30. What do I put in here? W square over? And in here, W square over 30. Good. So I do not have fixed like this. I have pin fixed. I need to get rid of this moment. I need to get rid of this moment. I have to make it 0. Is it positive or negative? Positive or negative? Look, another way of asking you, clockwise, what kind of clockwise? Positive. 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 Clockwise is positive. So to kill it, I need to put a minus WL squared over 20. Let me change it a bit. So to kill this moment, to put a negative, I have 0. I need to send 50% of this to the top. And that is WL squared over 40. I kill this one with an equal and opposite. I need to send 50% because the carryover factor 1/2. So now, look, this is negative. This is also negative. I need to add those two. I need to add those two. It's going to give me the fixed end moment in here. So I kill this one equal and opposite, carry over, take 50% across. Those two are the same sign. I need to add them. And that is going to be my fixed end moment in here. Any question? You want me to repeat it? Not that bad still. You want me to repeat it? Okay. Look. This case in here is not in the table. It's not in the table because, look, 10 is at the pin and 0 is where the moment is. The case that I have in here is reversed because mine, 0 is in here, is reversed. So what I have in my case is reversed than this. Is the 0 and the maximum here. So I start from this one, I just reverse. I put 0 and the maximum. If I reverse, I have to reverse the moment. And this is what I did in here. I started, look, the same that I have in here, but fix. I put the moments and I asked everybody, they told me W square root 20 come here. W square over 30 come to here. I need to get rid of this moment because I have a pin in here. So I put an equal and opposite. It's a positive, W square over 20. I put a negative. I have 0, like in here. So I don't have a fix. I had a pin because it's 0. But since I put this moment on this side, the carryover factor takes 50% across, and it's W squared over 40. Negative, and I had already a negative W squared over 30. I add those two, and that is going to be my fixed moment. That's what I did. Can we add this to the table? Listen, FOMO is an open notes, open book. You can add anything that you want to the table. That would be a good idea. Do whatever you can that is legal. And this is legal. Yeah. Any other? And we add, isn't the moment EF0 is a pin? EF? You talking about video? You talking about this moment? Oh, we can, if no, it cannot be a pin in here because it's going to collapse. Huh? But if you, no matter what, if you had, instead of, look, I'm going to change something. That's a good point. Now I had changed the load. I put this on the top and this is there. Do we have this case in the table? Look at the table. Look, the maximum and zero. With the change that I have made, can I use the table? Yes or no? Directly. Yes, that's correct. Huh? So you have to be very careful whenever you look at how the loading is given. Any other questions? Okay, Christina, never mind. Okay, so what about this loading? B, C, there is a moment at B and there is a moment at C. Hopefully, the solution to this problem. Oh man, I don't know if I already given it to you, but check. Otherwise, I will give you this. Anyway, the question I have to ask you: look, there is a moment at B, there is a moment at. Look at this case and look at this case. For my problem in here, should I use this one or this one? Left or right? Left. But left, I have to modify. For the left, I need to put the load in here. I need to move this moment to here and that moment to the other side. Exactly. So this I had to do, move this to here and swap the moment. Good. This is a problem to find the vertical deflection under this load. Okay, I will post it later. Is this the terminal or in the terminal? In the terminal. Fix. This is a rigid joint. This is a rigid joint, a pin, pin. Member AB, 4EI or 3EI? 4. I'm going to put 4EI over 20. Because it will develop a moment at A and a B. Member BC, 4 or 3? 4. Similar to what we done before, 4EI, so this is 0.5 and 0.5. What about CD? 3 or 4? 3. Good. 3E over. What about CE? 3. Good. At joint C, how many distribution factors do we have at joint C? How many distribution factors? 3. CB, CD, and CE. Fixing moment. do I need to use W square over 12 and W square over 12, or it's easier to use W square over 8? W square over 8. And the W square over 8 in here is going to be counterclockwise or clockwise? The moment here, W square over 8 is counterclockwise. Now BC, PL over A, or 3PL over 16? Over A, good. One more. Before I forget, the exam tomorrow at 11 o'clock is 1 hour or 2 hours exam? Anybody in the 1 hour or 2 hours exam? 10 to 11:30. And how many people are in that class? Just say me. How many? 2, 3. Whole bunch. Okay, listen. Because of really, I don't want to hurt you. I want to help you. I'm gonna move the review. If I move review to noon, to 12, I'm oh, oh, you don't worry. There's only one class to 11 hours. So if I move it to noon to 12, am I gonna hurt anybody? No. Okay. So look, I'm gonna move it. I'm gonna move it the review from noon until about 2 tomorrow. Right. So I'm gonna send the email to remind you. Somebody's gonna record it, but sometimes they forget. But I'm gonna move it. See, nobody's complaining, and I don't care. No, if nobody's complaining. I'm gonna move it to noon. So tomorrow from 12 until about 2. Is that okay? Okay, good. All right. So let's go back to C. I go back to this problem. Yeah, record anything you want, record it. Somebody usually record it. But yeah, go ahead and record it tomorrow. Pictures. I can take pictures and send it to you. Don't send it to me, send it to somebody else. Okay. Question. Determinate or indeterminate? Indeterminate. Now the next question is the most important. Look, this is a wall. This is another wall. And this is a pin. We have gravity load. This case is not in the table. But we're gonna break it into a rectangular and a triangular. So we're gonna use superposition for the fixed moment because this is not in the table, a rectangular and triangular. Is there any way that you pushing this that the joint A is gonna move? Is there any possibility no lateral movement? What about instead of pushing, if you pull Superman, everybody in the class pull here. Is there any way that A is gonna move? No. So there's no lateral movement in here. No lateral movement, that means one moment distribution. There is a moment at A. this is a rigid joint, have moment at BA, BC, and BD. 3 moments in here. Dimension of moment has to be equal to 0 equilibrium. This is also a rigid joint. It had a moment DE and DB. Moments equal and opposite. There is a wall, there is a moment in it. And this one, because the pin, there is no moment in here. So AB, 4EI over L or 3EI? 4. That's correct. 4EI over 20. What about BC? 4 or 3? 3EI. Beautiful. 3EI over 20. What about BD? 4. Good. And ED? 4. Good. So you can see that joint D, both of them are 40 over 20, distribution factor 0.5, 0.5. Distribution factor 0, 0, and 1. And in here we have to compute the distribution factor. This is what I was talking about. We don't have in the table. We don't have in the table that case, but it's going to be a rectangular. It's going to be W squared over 12 and W squared over 12 combined with a triangular. And look at the way it's given in here. Maximum and 0. If this is a rectangular, this value, the rectangular is going to be 10 W squared, and we're going to have the W is 10. For the triangular, what is the value of the W for the triangular? 5, correct. And look, the triangular go from 0 to a maximum. So the moment, this moment, it goes from 0 to the maximum. This moment goes to this side, and that moment goes to the other side. So to this WL squared over 12 on this side, do I need to add W squared over 20, or I need to add W squared over 30 to this one? 30, good. So to this W squared over 12, I need to add W squared over. So to this one, I need to add W squared over 20. Good. And this one, because it's in the middle, it's going to be PL over A and PL over A. But the one on the top is going to be positive or negative? This moment is PL over A, positive or negative? You sure? Yes, and that's correct. And the one in here is positive. So this is a very simple problem. One more. And we just add the value. Yes, correct. Because we're doing superposition. So you broken that load into a rectangular and a triangular. And both of them, on the left, both of them, they are negative. On the right, both of them, they're positive. You just add the value. And I did a sample in class that I had a rectangular and a point load. But that is a superposition. So when we look at this program, first question, determinant or indeterminate? Indeterminate. And now, do we have lateral movement or side sway? Yes or no? There's lateral movement? Yes. And probabilities are high that which way is going to go, to the left or to the right? To the left. Whenever we have lateral movement, we need two moment distribution. Fixed support, there is a moment. Rigid joint, two moments, BA and BC. Another rigid joint, three moments, because I have to remember, CB, CD, and CE. And in here we had EF, joint E, two moment, EC and EF. And in here, of course, no moment. AB, 4 EI or 3 EI? BC, 4. So you can see that distribution factor BA and BC are equal to 0.5. CE, 4 or 3? CE, 4 or 3, I 4. CD, 4 or 3? 4, 4, EI. And finally, EF, 3. Fixed end moment, B, C, and CB, WL squared over 12. This one is negative, this one is positive. Member CE, W squared over 12, negative, W squared over 12, positive. PA, no low, no fixed end moment. CD, no low, no fixed end moment. EF, we have to look can I use this one? Yes or no? No. And Fomo asked me, Fomo Ray had this moment in his table. Any question about anything? Any question, something that you are not sure? Okay, so look, let me repeat. Tomorrow, our review is gonna be at noon. I'm gonna continue until 2 or until I get tired. What do you mean it should have two moment distribution? Well, whenever we had this frame, it's gonna do this. Let me look for a different color. So this problem is going to have a lateral movement. So we're going to break it. And I don't know if you have to go to another class. Yes, I need 5 minutes to just go over the moment. So what we had to do is moment is number one, no sideways. To stop the lateral movement, we put a force in here. See, it's like we put Superman, Superwoman, everybody stopping. So no lateral movement. We're gonna do our first moment distribution by using Divers Curve 12, Divers Curve 12, all the fixed moments and the distribution factor. And whenever we finish the first moment distribution, we're gonna compute the shear forces at the base. And the way we do it, we had the moments in the column, the moments in the column, the moment in the column, and this load has to be in there. We find it. Summation of forces in X equal to 0. We find P. In addition, we need to put the same frame and this is moment distribution number 2, size. So we're going to push it with a force Q. This force Q is opposite to P. This is going to do this. There's no load in this frame. So we have to find fixed moment. And the way we find fixed moment is based on, at the bottom of this table, there is a case that whenever there is a support movement, if both of the support move at the same time, no moment, but one stays, one move, it creates 6 EI delta over the square, 6 EI delta. Both of them same magnitude, opposite to the movement. Whenever we had only a fixed support and roller, is 50%, 3i delta. So we're gonna come here. And we're gonna assume the moment. Since the moment is here, 6 EI delta over the square. Movement goes in that direction. The moment go in the opposite. Six EI delta over the square, both of them 6 EI delta. So all of them in here, they're 100. Assume. Those are the moments assumed for my moment distribution number 2. However, this one in here is 3 EI delta over L squared. This moment in here is 3 EI delta over L squared, that is 30 squared. The only thing that they have in common is the delta. So this one in here is 6 EI delta over 20 squared equal to 100. So this moment, 6 EI delta over 20 square equal to 100 delta is equal to 100 times 20 square over 6 EI. This delta, I'm going to put it in here. So this is going to be 3 EI over 30 squared times delta, 120 squared over 6 EI. And whatever moment, whatever number is in here, I put it in here. Is that 200? So what is the value? Do the computation real quick. Anybody? Everybody left already? Twenty-two. That's correct. With this moment, we do our second moment distribution. These are my fixed moment for moment distribution number 2. I'm going to find the shear forces. And I do summation of forces in X and solve for Q. Any other question? P and Q, I already put it. P and Q. So we have like there's a moment negative E. What do you mean it should have two moments? Is there was a moment in the program? Definitely. So for F, we would have like there is a moment in half of that moment at E. What are you talking about? I don't know. For F. Oh, F, we don't have a moment. You're talking about we're going to create a formula like we did before. So no moment in here. We're going to create our table by using the case of FOMO wanted to put in the table. And the bonus question is the determinant. Man, I don't remember FOMO. It's just, I'm so tired. I'm me tomorrow. Any other question? Are we going to have this type of problem in the final side where from 0 to 31? Look, I don't know what I put in the final. What I want you is to understand everything. I want you to make sure that you understand everything as much as you can. Any other, any other question? Okay. So tomorrow, see you tomorrow at noon. Good luck in your exam. Good night.